Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving the ratio of two sums with powers of I. I guess you could call this a homemade problem. Hopefully you do know what it means. We have 1 plus I squared all the way up to I to the power 4n, where n is a positive integer, and in the denominator we have the same thing all the way up to I to the power 2n. And we're going to find the ratio of these two sums. In other words, we're going to simplify this as much as we can. We're going to look at different patterns. We're going to explore a couple different interesting things. All right, so let's get started. To get a better idea about what this sum is going to look like, because it might look like something in terms of n, right, at the end, kind of like a function of n. Or it could be maybe something as simple as 1 or I or negative I or even 0, right? So let's go ahead and find out what that's going to look like. And we can get there by, replacing n with certain values, such as n equals 1. Let's start with the smallest positive integer. What happens if n equals 1? Now, if n is equal to 1, you're going to be getting 1 plus I squared. Obviously, this sum is going to go all the way up to the 4th power. And in the denominator, you're only going to have 1 plus I squared, the first three terms, right? That's where it ends. So let's find out. You hopefully know that when you add powers of I that are consecutive, they're going to cancel out in groups of 4. But it doesn't matter which one is left over because they're going to be the same. So it's kind of like a cycle, right? How do we simplify this then? There are 5 terms in the numerator, and I can just go ahead and get rid of these. And if you notice, I squared is negative 1. I to the 4th is 1, so they're going to cancel out. And I to the 3rd is negative I, remember that. And I is positive I, so these two are also going to cancel out, leaving us with 1. Great. This is nice because the numerator is always 1, thanks to 4n being a multiple of 4, right? But at the bottom, we get I squared plus 1, which is 0. So they cancel out, and we end up with 1 over I, which is negative I. Multiply the top and bottom by negative I, which is the conjugate, right? If you want to write it in the simplest form, obviously. Let's go ahead and explore a little bit more. How about n equals 2? Don't worry, I'm not going to go through all the integer values. We can't do that. But I want to show you a couple to kind of give you a feel, okay? So with the n equals 2, our numerator is going to end with I to the 8th. So I'm not going to write the whole thing, but let's just write a couple terms to indicate the pattern. This is going to end with I to the 8th. And then at the bottom, I'm going to have 1 plus I squared plus I to the 3rd plus I to the 4th, just like the previous numerator. Great. If you look at the numerator, you're going to notice that there are 9 terms. That's good because we can make 2 groups of 4. And everything is going to cancel out except for one of the terms, and in this case, it happens to be 1. And even if you canceled everything but the last term, you would still end up with 1 because it wouldn't matter, right? At the bottom, though, we're still going to get 1, just like the previous one. It's going to be 1 over 1, which is 1. Wow, that was simple, right? Looks like we're getting 2 different answers. Now, here's the million-dollar question. If n is equal to 3, am I going to get a different value, or am I going to get one of these? I'm not going to do n equals 3 because I don't want to spoil the surprise, and I want to proceed with something else, which is going to be fun. So we're going to express the result in an interesting format, which I call a piecewise function, or some people call piecewise defined. Anyways, let's get to work. Now, instead of looking at numerical answers, I want to generalize this. First of all, one thing to keep in mind is the numerator is always going to be a multiple of 4, the last power. So this is good because we know that everything is going to cancel out except for one of the terms, in which case we always get 1. So the numerator is 1 regardless of n. But n is an integer. What can n be, right? N can be even or odd. So we're going to split up into 2 cases. We need to look at 2 different cases because the answers will be different. And we've seen with n equals 1 and n equals 2 that the answers are different. We did not go to n equals 3. If you get a different answer for that, that means it's a little deeper than that. But let's go ahead and check the even and odd first. So if n is odd, then we end up with something like, let's say, and we can kind of isolate this. Look at it in isolation, right? Let's say n is equal to 3. So we're going to get 1 plus I squared all the way up to I to the 6. And as you know, this is 7 terms. 3 terms are going to stay. They're going to cancel out, leaving us with I. So it doesn't matter what kind of odd numbers you have. You're always going to have 3 terms left over. Make sense? So when n is odd, you're going to have 3 consecutive terms. Cool. What happens if n is even? It's going to be even better, right? Evens are better. Even. So in this case, you can say, hey, suppose n equals 4k, and then 1 plus I plus, I squared, all the way up to I to the power 4k. If we know that this is equal to 1, so when n is even, we're going to get 1 in the denominator. But denominator, the numerator was always 1. In the odd case, we got an, what did we get? I. Okay, this was an I. So let's go ahead and summarize the results. Let's write this as a piecewise defined function. And then we're going to look at something else, which I think is pretty interesting. So we can basically say the following then. Our sum, which is defined as follows. Of course, I'm assuming at the bottom here that n is greater than 1. If n is equal to 1, then I squared and I to the 2n coincide. Make sense? Okay. Now this can be expressed case by case, such as if n is odd, and if n is even. Make sense? And you can graph these, right? Okay. Now, if n is odd, we got 1 over I, which is negative I. Remember that one too? Okay. So we get negative I for the sum, the whole thing. Okay? And if n is even, we get 1. Nice. But guess what? We can make it nicer, can we? So my goal is to express this as a single function. I don't want if, and then, whatever. I want a single expression in terms of n. Can we do that? And the answer is yes. By taking advantage of something called geometric series, right? Isn't that awesome? First, when I solved this problem, I didn't really think of that. And then I'm like, how can you express this, right? How can I get negative I when n is odd, and how can I get 1 when n is even? Can you get it with a single power of I, like I to the power 3n plus 2 maybe? Is that possible? Let me know in the comment section. But here's what I'm going to come up with. So if you use the geometric series formula for the numerator, you're going to get 1 minus I to the power 4n plus 1, divided by 1 minus I. And for the denominator, you're going to get 1 minus I to the power 2n plus 1, divided by 1 minus I. Do not cancel out the 1 minus i's, because if you do, and let's say, actually, is that going to be a problem? Let's test it out. How about that? The best way to find out, right? Now, if you cancel those out, I don't think that's going to be an issue. We're going to come up with something like this. Now, in this case, we kind of have to think about it wisely. This can be split up into I to the power 4 to the power n times I, and this can be written as 1 minus I to the power 2. So I should put the 2 inside, right? I to the power 2 to the n times I, because I to the first power is I, right? Now notice that I to the fourth power is 1. So this is just going to be 1, leaving us with 1 minus I. That's nice. But here, I squared is negative 1, so we're going to get something like this. I'm going to write the I first, and then negative 1 to the power n, because that's an exponential. Yay! It worked. Actually, we can cancel out 1 minus I, and that should be the single answer. Isn't that cool? We can express it. Now, let's go ahead and explore how this works. If n is even, then negative 1 to the power n is going to be positive 1, and this is going to be 1 minus I over 1 minus I, which is 1. Beautiful. When n is odd, which is the odd case, negative 1 to the n is going to be negative 1. And from here, you're going to get 1 minus I over 1 plus I. But if you multiply by the conjugates, which is 1 minus I over 1 minus I, this is going to be a 2. This is going to be a negative 2i. And you're going to get negative I. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care and bye bye.